It's been a while since I did anything with the BBC microbit here, so I thought what I might do is connect this up to this big LED. So this is a 10 watt LED, and so I wanted to flash this LED and then see how far away I can see this light, how far away from the house I can see the light. So obviously this is a low power device, it's only a 3-volt device, and you can't provide very much current through these interface pins here. So I've got some circuitry here which I'm going to use to switch the current that this LED needs. So this is a 10 watt LED, so there's lots of different LED chips on here, and these generate quite a lot of heat, so I've mounted it on an aluminium heatsink here. Not sure where the heatsink came from, but this is a good size for this, so that this will be used to dissipate the heat from this LED. So I'm generating enough current to drive this at over 8 watts. So I've got something like 700 milliamps coming through here to light this LED. So let me describe the circuitry I'm using to drive current into this LED. So here's the microbit over on the left hand side, and so we've got a couple of transistors that we're using for switching the LEDs on and off. This is the power LED here, and the other part of the circuitry here is this. So I've got an LM317 which is set up in a constant current mode, so we get 700 milliamps of current flowing through the LEDs. Because one particular thing about LEDs is that you have to supply a constant current to them. So sometimes with smaller LEDs we just put a resistor in series. That's less practical with the bigger LEDs, because you end up with a big resistor that has to dissipate a lot of heat. So here we're using a constant current source, and without the constant current source, what would happen is the LEDs would draw more and more current until they got really hot and failed. So this is very much needed here. So the MOSFET here, this switches the current on and off. So this is what allows us to make the LEDs flash. And this was just a particular MOSFET that I had lying around in my transistors box, so I used this one. And then this smaller bipolar transistor is used to switch the gate of the MOSFET, and I actually need that in this case because this is only a 3-volt device. The microbit is only a 3-volt device, and at 3 volts, with the gate at 3 volts, this MOSFET's not completely switched on. So I need another transistor here to allow me to switch the gate on and off using the 12-volt rail up at the top here. Unfortunately, it also inverts the signal, so I have to treat on as LED off here and off as LED on. So there's a bit of logic in the software to allow me to do that. So looking at the software side now, so we're here on the MakeCode microbit site, and so you can see on the simulator what I've programmed the microbit to do here. The top left LED is flashing 20 times, and at the same time we're also switching the interface here, the P0 pin on and off. So this pin is what's going to drive the MOSFET to switch the LED, the power LED, on and off. So looking at the main function here, flash, so what I'm doing here is I'm switching the digital pin P0, and I'm also switching off the LED, the top left LED, and I pause for 100 milliseconds, and now I'm setting the pin P0 to 1, and also switching off the LED on the display, and then again waiting for 100 milliseconds. So basically what we're doing here is we go around this loop 20 times, flashing the LED on the microbit and changing the pin at the same time, and then the this is the top loop of the program, so we do 20 flashes and then we pause for 4 seconds. So we get this sequence of rapid flashes and then it goes dark again. So I'm hoping, that when we are looking from some distance to see the power LED, we'll be able to pick it out from anything else that's flashing nearby. So we can also look at this in the blocks language. So if you're more familiar with how to program using blocks, you can see, so we've got the forever block here, which is calling many flash to do the 20 flashes with the pause of 4 seconds. And so here, many flash, you can see we've got the 20 times calls to flash, and then finally here the function that actually does something, flash. So this is switching the pin and the LED on, and then waiting, and then switching the pin and the LED back off again. So I've programmed that into the microbit. So now all we need to do is connect all these things together, and then we can take the video camera for a trip and look down from the hill and see if we can see the microbit flashing from a distance. So here's the microbit all wired up. So it's flashing the big LED now, which is taped to the window. You can see it there in the center. It's actually surprisingly easy to spot. So I was thinking, because it's around Christmas, there would be a lot more flashing lights that would be stopping me from seeing it, but you can see the flash is really quite easy to spot. There we are, in extreme close-up. You can actually see there's a reflection, so as well as the light itself, there's a reflection in the roof of the conservatory, the glass roof of the conservatory. So here we are back in the house, and that was great. That's a real success, I thought. So we can drive this power LED from the microbit, and it's bright enough that we can see the light all the way from, over a kilometre away, which is really interesting. So that's another interesting thing we can do with the microbit. So this is most likely my last video of 2017, so let me just wish you a happy new year and a prosperous 2018.